Okay, this lesson we're looking at Unit 7, Chapter 7. And we're going to be looking at exponential functions, of course, which is what Chapter 7 deals with. But we're looking at solving exponential equations, and we're going to look specifically at like bases. This is from Section 7.3 in your text, solving exponential equation. And again, the focus is going to be on determining the solution of an exponential equation in which the bases of the powers in which the bases are powers of one another. In other words, solving equations that have like bases. That's all that's saying. Let's jump right into it. Example 1. Change the base of powers. Rewrite each expression as a power with a base of 3. The first thing we need to be able to do is rewrite expressions with a base that we want to write it as. In this case, we're writing it with bases of 3. Pretty simple to do here. My 27, of course, can be written as 3 to the power of 3. My base is 3, my exponent is 3. I'm going to rewrite my 9 squared with a base of 3. It's simply 9, I'm going to write it as 3 squared. Of course, it's already raised to the power of 2. So if I rewrite this, power to a power, you remember you multiply, so I get 3 to the power of 4. So I've rewritten 9 squared with a base of 3, and it's 3 to the power of 4. This one requires a little more work, doesn't it? I want to rewrite all of this with a base of 3. So I'm going to rewrite my 27 first as 3 cubed. Don't forget that's already raised to the 1/3. The cube root of 81 squared, I got to get rid of the radical here. First thing I'm going to do is rewrite the radical as a fractional exponent, and it becomes 81 to the 2/3. Now let's continue. This is multiplied together. Again, just like right here, a power to a power you multiply, here I'm going to multiply the powers together. 3 times 1/3 is 1. So I simply get here 3 to the power of 1 times, I'm going to rewrite my 81 with a base of 3. That is 3 to the power of 4. Don't forget it's already raised to the power of 2/3. So I get 3 to the power of 1 times 3 to the power of a power to a power we multiply. That's going to give me 8/3. Okay, we have one step left. I want to rewrite this expression with a base of 3. Right now I got the expression with 2 bases of 3. So I combine these two, and how do I multiply bases with this? How do I multiply like bases? What do? I add the exponents. So 1 plus 8/3. This will become 3 to the 8/3 plus 1. I'm going to rewrite my 1 as 3/3 plus 8/3, and I get 3 to the 11/3. There's my base of 3. Done. 3 to the power of 11/3. That will require a little more work. Remember, there's a lot of laws of exponents you need to remember. A power to a power you multiply. When you multiply like bases, you add the exponents. Just some rules that you need to recall. Solve each equation. We're going to be solving equations now with like bases. Very important rule here is this. If the bases are the same, the exponents are equal. So my goal here is to solve for the exponent, because look where your variable is located. Your variable is located in the exponent. So using this simple rule that I've written here, if the bases are the same, the exponents are equal. If I can rewrite these two expressions on each side of the equal sign with the same base, then my exponents would have to be equal. So I'm looking at this has a base of 4. This has a base of 64. Could I possibly rewrite two of these with the same base? And the answer is yes. I can rewrite 64 with a base of 4. 64 is 4 to the power of 3. 4 times 4 times 4 is 64. So I've rewritten my 64 as 4 to the power of 3. Now I'm going to write this as 4 to the x plus 2 equals 4 to the power to a power you multiply, 3x. Note I now have like bases of 4. If the bases are the same, the exponents are equal. So therefore the exponents must be equal, so x plus 2 must equal 3x, solving for x, I got 2 is equal to 3x subtract x, which is 2x. So of course, x must be equal to 1. Pretty simple, really. The key is to try and get like bases. If you're solving for an exponent, try and get like bases. Let's look at the next example. 4 to the 2x equals 8 to the 2x subtract 3. Look at your bases again. I'm solving for the exponent. My variable's in the exponent here, so I want to try and get like bases. 4 and 8. Could I rewrite 4 and 8 with the same base? The answer is yes. Now some of you may be thinking that you can write it with a base of 4, but that's not true. I can't write 8 with a base of 4. But I can write 4 with a base of 2, and I can write 8 with a base of 2. And that's exactly what I've done. I've written 4 as 2 squared, I've written 8 as 2 cubed. A power to a power you multiply, so I get 2 to the 4x equals a power to a power you multiply. Don't forget to multiply the 3 by the 2x and by the 3. 2 to the 6x subtract 9. I now again have that very important rule of like bases, so the exponents have to be equal. So 4x is equal to 6x subtract 9. So if I solve for x, I get 4x subtract 6x, which is a negative 2x equals a negative 9. Divide by negative 2, of course, and I end up with x is equal to 9 over 2. There's my solution. I've solved that equation for x. Let's have a look at C. Now look at C here. I got 1 over 27 and 81. Look at your bases. My base right now is 1 over 27 and 81. You got to think, how can I rewrite both of these with the same base? What number do you think you might be trying to reach here? I'm thinking 1 over 27 and 81. I can rewrite that with a base of 3. Let's do it. What we want to do is simply rewrite the 27 first with a base of 3. So I'm going to write that as 1 over 3 cubed to the negative 2. 81 is 3 to the power 4 to the 2x subtract 3. Now how can I rewrite 1 over 3 cubed with a base of 3? What I do is I bring the 3 cubed up to the numerator, and when I do that, the sign of the exponent will change. There we go. On this side, a power to a power I multiply, I get 8x subtract 12. On the right side, or sorry, on the left side, I get 3, a power to a power I multiply. I get 3x equals 3 to the 8x subtract 12. Again, I got the like bases are occurring here, bases of 3, so therefore the exponent's got to be equal. 6 is equal to 8x subtract 12. 6 plus 12 is equal to 8x, so that will be 18 is equal to 8x. So x will equal 18 over 8, which of course is 9 over 4. 9 over 4, that solution. Now, what about D part? I'll choose a different color to do D in as well here. I got the cube root of 16 squared, and I got 1 over 8. Again, you want to think about what the bases will probably look like here. How can I rewrite this with the same base? I'm thinking a base of 2. A base of 2. The first thing you need to do is get rid of this radical. We're going to change, and that's really level 1 work here. We're going to change our radical from a radical to a fractional exponent. So I'm going to rewrite that as 16 to the 2/3. Equals, again, the 1 over 8, I'm going to write that as 2 cubed. To the negative 3x subtract 4. 16 is 2 to the power of 4 to the 2/3. Notice I wrote my 16 with a base of 2. You see, I'm really getting close to my base of 2 now, which is what I'm trying to reach here. On this side, I'm going to bring the 2 cubed up, and it becomes 2 to the negative 3. The sign of the exponent changes when you move something from the denominator to the numerator or vice versa. Don't forget a power to a power you multiply. So I got 2 to the 8 over 3, 4 times 2 over 3, equals 2 to the 9x plus 12. All I need to do again is make the two exponents equal because I already have like bases of 2. So I make the exponents equal and I proceed to solve for x. So I get 8 over 3 is equal to 9x plus 12. 8 over 3 subtract 12 is equal to 9x. 8 over 3 subtract 12 is 36 over 3. equals 9x. 8 subtract 36 is 28, and it's a negative 28 over 3 equals 9x. And I want to get x by itself, so I'm going to multiply both sides by 1 over 9. And I get an answer of negative 28 over 27 equals x. Negative 28 over 27. There's my final answer for x. Now let's do a few multiple choice to practice this. Again, I would encourage you to maybe pause the recording at this point and try this one on your own first, then continue the recording and see how it's done. Okay, I'm going to proceed to do this one. Solve for x. First thing we're going to do is we're going to rewrite both of these with a base of 2, and I'm going to rewrite my 16 with a base of 2. So 4 is 2 squared to the x times 2 to the x plus 3 equals 16 is 2 to the power of 4 to the 2x subtract 5. This becomes 2 to the 2x times 2 to the x plus 3 equals 2 to the 8x subtract 20. Notice on this side again, I got a 2 to the 2x times 2 to the x plus 3. I want to get a base of 2 only on this side. So how do I multiply like bases? Well, you should recall to multiply like bases, we add the exponents. So 2x plus x plus 3 gives me 3x plus 3 equals 2 to the 8x subtract 20. I now have like bases, so the exponent's got to be equal. 3x plus 3 is equal to 8x subtract 20. 3x subtract 8x is equal to a negative 20 subtract 3. Negative 5x is equal to a negative 23. X will equal 23 over 5. 23 over 5, the correct answer is D. Okay, another example here. Solve for x. Again, look at your base. I got a cube root of 9. Again, you want to remember that I can rewrite that. Again, you may want to pause the recording. Just remind you to do that if you want. But I'm going to rewrite this as 9 to the 1/3 equals 27 to the 4x subtract 1. Now immediately you should see I'm going to get a base here of 3. I rewrite the 9 as 3 squared. I rewrite the 27 as 3 cubed. And it becomes 3 to the power to a power you multiplied, which is 2/3 of course, equals 3 to the 3 times 4x subtract 1 is 12x subtract 3. I now have my like basis, so the exponent's got to be equal. Oh, I left out my x there, sorry. Let me fix that. Now let's proceed to solve. 2 over 3 plus 3 equals 12x. 2 over 3 plus 9 over 3 equals 12x. And we're going to get 11 over 3 equals 12x. Again, I want to get x by itself, so I can either divide by 12, but I'd much rather multiply by 1 over 12 with fractions. It's so much easier. 1 over 12 times 12 is x on this side, and I get 11 over 36 on this side. Correct answer is D, 11 over 36. I think I have one more example left, and then we're done. I got 1/2 to the 2x subtract 3 equals 32 to the 1 subtract 4x. Again, you want to think about like bases here. Think about the 1/2 and the 32. I'm going to rewrite both of them with a base of 2. Rewrite the 1/2 as 2 to the negative 1, first of all, to the 2x subtract 3. Rewrite 32 as 2 to the power of 5 to the 1 subtract 4x. I got 2 to the negative 2x plus 3 equals 2 to the 5 subtract 20x. There are your like bases, exponents are equal. Negative 2x plus 3 equals 5 subtract 20x. Negative 2x plus 20x equals 5 subtract 3. 18x is equal to 2. X will equal 1 over 9. Answer again is D. Okay, let's look at the key ideas here to conclude the lesson. Some exponential equations can be solved directly if the terms on either side of the equation, either side of the equal sign of the same base, or can be rewritten so that they have the same base. And that's what we've been doing, isn't it? If the bases are the same, then you equate the exponents and solve for the variable. If the bases are different, but can be rewritten with the same base, you use the exponent laws and then equate the exponents and solve for the variable. And that's exactly what we did in this lesson. And that ends the lesson.